Hey guys, chapter 6, we are going to be taking a look at equations and analyzing how to plug in variables and solve for a variable. So if you take a look at question number 1, you can see that we have the equation x plus 7 equals 12. Now right off the bat, you could obviously do that in your head. You know that a number plus 7 equals 12. The number is 5. Obviously, the first 3 problems pretty much can do most of those problems in your head. But what we want to do is help you to also understand there's a way in which you can balance this equation. So think about x plus 7 equals 12. And what I want you to do is I want you to get the variables, meaning the letter, on one side and the numbers on the other. So instead of kind of just trying to do everything in your head, I want you to start balancing the equation. How we get 7 to the other side is we take away 7 from both sides. You're going to look at the expression and you're going to think about, is it a positive, is it a negative? You do the opposite. So if we take away 7 from both sides, you obviously have 0 and then you have a 5. And so what that leaves is x equals 5. And that is your answer. Take a look at the next question. You have x on the left. We want to get this 9 to the other side. What we're going to do is we're going to look at the value of 9. We're going to do the opposite. So what we're going to do is we're going to take away, I'm going to use a different color to just kind of show you. We're going to take away 9, and 9 minus 9 is 0. It's gone, but whatever you do to the left side, you have to do to the right. So if we take away 9 from 2, that's a negative 9. We're left with a negative 7. And take a look. This will make this equation true. We have a negative 7 plus 9. That's going to equal 2. So plugging back in the value of this variable will help you to figure out whether you solved it correctly. So x is equal to negative 7. Okay, and I didn't write the answer for number 1. I apologize. So once again, we are basically balancing equations by looking at the value of the number and then doing the opposite. In this case, you can see when we add 4 to both sides, sorry, that's a funky 4, that you end up getting x, which is equal to 9. And then obviously if you plug that in, 9 minus 4 equals 5. So x is equal to 9. Okay. In this case, you don't need to balance the equation. What you need to do is you need to solve for x. Take a look and you can see there is a coefficient of 9. So once you've balanced everything, number on one side, the coefficient and variable on the other, just divide by the coefficient. And that'll get the variable by itself. In this case, x is by itself. 9 divided by 9 is 1, so that means x is 1x, and then 36 divided by 9 is 4. And if you plug this back in, you know that 9 times 4 equals 36. So therefore 9 times 4 is the 36. 9x is 36, x is equal to 4. So 4 is the answer. In this case, what you're going to do is you're going to divide by a negative 3. Remember, you're dividing by the coefficient. This coefficient is negative 3. And what it does is it basically, negative divided by negative is a positive. So that's a positive a, and a is equal to negative 5. Why is it negative 5? Well, because we have a positive and negative number. When you divide a positive by a negative, you get a negative. So a is equal to negative 5. And if you take a look at this, if we multiply a negative 3 times a negative 5, that equals the positive 15. So it does solve that problem. 6 is a little challenging because we have a fraction. We need to get b. We need to get b by itself. So what we're going to do is we're going to multiply both sides by the denominator, negative 3 over 1, and we're going to multiply a negative 7 times a negative 3 over 1. Remember, whatever you do to the left side of an equation, you have to do to the other to keep it balanced, like a teeter-totter. So if you take a look at this, negative 3 times b is going to be a negative 3b. Okay? And then if we multiply 1 times a negative 3, remember, we're multiplying fractions right now, we get a negative 3 again. We'll take a look right there. That's why we're doing this. -3 divided by a -3 is a positive number. It's a positive 1. Therefore, b is now by itself. Well, since we multiplied these two fractions by one another, now we kind of have to multiply these two numbers by each other. These you can consider this to be a fraction as well. -7 over 1 is -7. So we're going to multiply -7 times a -3, and we get a positive 21. And it's 21 over 1, which is still just 21. So as you guys can see, 6 is 21. One of the challenges there is getting that b by itself, and in this case, when it is a fraction, you need to multiply by its reciprocal, and that is -3 over 1. I'm going to just show you how to solve for n. In this case, you would divide both sides by -3. Problem number 8, once again, you would multiply both sides by 3 over 2 to get x by itself. We are going to take away 6 from both sides, and you'll be able to balance the equation by showing that 4x is equal to 4. Don't forget when you're balancing the equation to get the x's on one side, the numbers on the other. So we're going to add 10 to both sides. And as you can see, then we're going to take away 5x from this side. And what's that going to leave us? Well, that's going to leave us a -2x equals 30. And then you can solve for x by dividing both sides by -2. You obviously heard the bell. I have to let kids in, and so I'm kind of rushing quite quickly. Remember, inverse or reciprocal basically means you're just basically flipping the numerator and the denominator. So 3/7, the inverse or reciprocal number of 3/7 would be the denominator over the numerator. So that would be 7/3. This is a mixed number, so what you're going to have to do is you're going to convert it into an improper fraction. 3 times 4 is 12, plus the 1 is a 13 over 4, and then you would just basically flip it into 4/13. So with that being said, guys, I'll just finish up where I'm going to skip the word problems. When you look at this expression, you want to kind of think about what this actually means with regards to a number line. And in this case, you can see that I have just found out that x is less than or equal to 12. Okay, so I had to balance the equation. Now I have a graph. Well, I'm going to include 12 because it is equal to 12. And now I need to think to myself, what is less than 12? Well, the numbers to the left are smaller than 12. And so any of these numbers to infinity are going to be less than 12. We're going to solve for m here. We're going to divide both sides by a -5. And we get m is greater than -4. So I have -4 here, but it does not include -4, so I cannot include -4. You can see that this dot right here is not including 4 or -4, but this is including 12. So that's the difference between greater than and equal to, and then obviously greater than. The dot, it does not include the number that it's marking. And so what number is greater than a -4? Well, once again, think about a number line. Anything to the right is greater than, anything to the left is smaller. For example, 0, those are all positive numbers to the right. To the left are negative numbers. So m is basically anything that is greater than the -4, and this is -4 but not including -4. So sorry I rushed those last few problems. I would definitely spend just a second to kind of analyze what these word problems mean, and I think maybe I can just kind of do that quite quickly. So 5 more than a number is not known. That's a variable. It could be any letter. And then 5 more, when you think of more, think of plus, addition. So x plus 5 is at most 11, so is equal to 11. Okay, the product of a number and 2 is at least, well, at least 20. You may see less than or and then obviously it has to be at least 20. Okay, so with that being said, I'm done. Good luck with chapter 6. I think it's self-explanatory, solving for a variable.